we have a function ln x multiplied by ln of x. So what we want to do, we need to apply L'Hopital rule. So keep one thing in your mind: the prerequisites for the L'Hopital rule are, it should be plus infinity divided by plus infinity right after plugging in the limit, or minus infinity divided by minus infinity, or 0 by 0. So first we need to make this form and then we can apply the L'Hopital rule. So how do we do that? If we write this x as 1 over x, then we see what happens. Since this is a numerator, so we can still write this x as a denominator, but of course we have to take a reciprocal of this. So now if you okay, let me draw a graph first. The graph of x-axis, x-axis, y-axis, and the graph of 1 over x is this. So I would write y is 1 over x, and this straight line passes through the origin, which is actually it bisects to first and the third quadrant. So this is actually y is x. And what is the graph of ln? The graph of ln is actually, since first of all this is the graph of exponential function, and the reflection of an exponential function along y equals x is actually the graph of ln. Y is ln of x. So this is ln of x. I'm going to use another color, it doesn't work. Okay, so the thing is that if I plug in the limit here, 0, what does it mean by 0 plus? It means like we are approaching 0 from the positive direction. So actually this is a positive direction, we are approaching to 0, this is 0. If I approach to 0 from this direction, so we see that this graph 1 over x goes to plus infinity. So actually this is plus infinity. But at the same time, if I approach to 0 from the positive direction for the graph of ln x, so you see that since we are approaching to the positive 0 from the positive direction, so this is this, so the graph of ln goes to negative y-axis, so this is minus y. Unfortunately, we cannot apply the L'Hopital rule here because these signs have to be same. So what we do, the trick is that we multiply the denominator by a negative sign. We can do it. Since we are multiplying here, so we have to multiplying outside. So this is minus 1. So right now if you see, this goes to, now we have which form? We have the form minus infinity divided by minus infinity. Since this graph goes to minus infinity, and this is like the way we discussed earlier, this goes to negative infinity as well. So we are in the situation to apply the L'Hopital rule. So this is minus 1. So for the L'Hopital rule, of course we have to take the derivative of denominator and numerator. The derivative of numerator is 1 over x, and the derivative of denominator is minus 1, remains as it is, and this is minus 1 and 1 over x square. So we simplify this, limit, this minus is multiplying by this minus, so it is positive. So this denominator goes up and this denominator goes down. So this is going to be x squared divided by x. So it means what we have right now, this is negative 1, limit it wasn't legible, so let me write in a nice way. So this is going to be minus 1 multiply equals, and we had x squared divided by x, and which is actually, this is negative. I'm messing up actually. And if you cancel this with this, so this is going to be plus. And the graph, I mean, if you are approaching to 0 from the positive sign for this graph, so actually it looks like this. Y is x, you are approaching to 0, but from the positive side, so of course the limit is 0 here. So at the end of the day, we are left with 0. So this is, so it means a limit exists and which is actually 0. So we can write in this way, limit for the function x ln of x is 0. Thanks for watching.